In this lesson, we are going to be looking on how to simplify rational expressions. So we'll get started here so you can see what that looks like. Here we have 3t cubed divided by 12t. We have a monomial on top and a monomial on the bottom. So the first thing we're going to do is we're going to look at the coefficients and see if we can simplify that. 3 and 12 are both divisible by 3. So if we divide both of them by 3, this becomes 1 and the 12 becomes 4. Now let's look at the t's. We have t cubed on top and t to the first power. So on top we have 3 t's and on the bottom we have 1 t. So the t on the bottom cancels out one of the t's on top. Or you can remember our rule that when you're dividing with exponents, t cubed divided t to the first power, you subtract the exponents, and that would be t squared on top. But I like to look at it as this one cancels out one of these, which leaves 2 of them. Now when we do all those lines and that crossing out, you have to be neat about this or you're going to get lost. There's the simplify the variables. I cross that out, and there's 2 left on top, and the t on the bottom goes away. So what's left? On the top, we had t squared left on top, and on the bottom, we just had a 4. So our final answer is t squared 4. This is what it looks like when we have monomials divided by monomials. But in rational expressions, we're going to have binomials and trinomials, and we're going to simplify them. So let's look to see how we would do this one. First of all, if you have a binomial or a trinomial, we're going to try to factor it. On the top, we have 3x squared minus 9x. We look for the greatest common factor of those two terms, and the greatest common factor that I see would be 3x. Remember, factoring, we have to now divide both of those terms by 3x to see what is left. 3x squared divided by 3x, the 3's cancel out. This 1x cancels out 1x up here. We're just left with x minus 9 divided by 3. The x's cancel each other out, and we just have 9 divided by 3, which is 3. So that's what the top looks like when we factor it. Now, if you look at the bottom, we also have a 2-term, a binomial. Notice it does not have parentheses around it. When you have 2 terms like this, and the parentheses are not there, but it's all alone, there's an assumed parentheses around it, but the parentheses are unnecessary when it's there by itself. So we have the binomial x minus 3 on top, and we have the binomial x minus 3 on the bottom. These cancel each other out. So all we have left is 3x. So you will see that as we're simplifying and as you factor, you're going to have a lot of stuff that you can cancel out. There's the x minus 3's left with 3x. Let's look at another example. Now this one, on the bottom, remember we said that if we have 2 terms and they're by themselves, this is a binomial, and we have to understand that it has invisible parentheses around it. Now, can you think of a number that you could plug into c to make this true? Since you have the c variable twice, it's standing for the same number. So let's just randomly come up with a number. Let's say we plugged 5 in for c. 5 divided by 5 plus 5. Okay, you can't cancel anything out there. So you would have 5/10, and that wouldn't work. So you can't cancel out a single monomial with a binomial. Even though you see the c's here, you have to consider c plus 5 as a package deal. It's a binomial together. So that one cannot be simplified. So you can't just randomly pick out a variable within a binomial or a trinomial to cancel out with a single monomial on top. Okay, here's one that's already factored, and this one's pretty simple because on top, in parentheses, you see a binomial t minus 1, and on the bottom you also see a t minus 1. Those are both binomials, so they can cancel each other out. If you were to fill in a number for that, say 5, this would be 5 minus 1, which is 4. This would be 5 minus 1, which is 4, and the 4's would cancel out. So you can do that. So what's left? On the top, we have nothing, but we have to have a placeholder, so we put a 1 on top. And on the bottom, we have the binomial t plus 2. Since that binomial is by itself, we don't necessarily have to put the parentheses. If it makes you feel more comfortable, you can put them. But when the binomial is by itself, you can leave the parentheses off. Okay, let's look at this one. On the top, we have k plus 1. That cannot be factored. But on the bottom, we have a trinomial. Let's see if we can factor it. Remember, this has 3 terms, and the leading coefficient is a 1. Do you remember how to factor 3 terms with a leading coefficient of 1? We used reverse FOIL. That is where you look at the last term, -5, and you think of factor pairs. For -5, we have 1 and 5 and 1 and 5. It has to be one of those 2 possibilities, but we want it to add to get a -4. Well, that has to be this set. So in factoring this, it would be k plus 1 and k minus 5. So that is factoring the trinomial on the bottom. I hope you remember how to do our reverse FOIL there. So that leaves us with k plus 1 on top, and then on the bottom we factored it to k plus 1, k minus 5. Now on the top we have a binomial. There's no parentheses, but since it stands alone, we understand that it has invisible parentheses around it, so it can cancel out with the binomial on the bottom. What does that leave us? Only a k minus 5 on the bottom, so we put the 1 on the top. Okay, look at this one. We have, oops. Took that a little fast. Remember when we had 2 terms when we were factoring, we always want to check for the difference of 2 perfect squares. Difference means it's a subtraction. Now we look at the first term. Is this a perfect square? Can we take the square root of y squared? We can, it's y. Can we take the square root of 16? We can, it's 4. So do you remember how we would factor that? We would factor it as y, take the square root of y, take the square root of 16, which is 4. So we'd have y minus 4 and y plus 4. So that's factoring the difference of 2 perfect squares, which we practiced in our last chapter. On the bottom, we have a trinomial with the coefficient of 1. So again, here we have reverse FOIL. So we think of factor pairs for 16. We have 1 and 16, 2 and 8, 4 and 4. We want it to add together to get a -8. So if I make both of my 4's negative, that would multiply to get a positive 16, and it would add together to get a -8. So notice we have y minus 4 twice, y minus 4 squared. This was actually a perfect square trinomial if you recognized it. If you recognized it, you would have known it was y minus 4 squared. But when simplifying, it helps to write out both of those, because here we have y minus 4 twice. And remember when we factored the top with the difference of 2 perfect squares, I'll show it now, we had y minus 4, y plus 4 on top. And then when we factored the perfect square trinomial, we have y minus 4, y minus 4. So it helps, instead of to write 5 minus 4 squared, it helps to see it 2 times, because now we see that we can cancel out one of the binomials on the top and one on the bottom, and that leaves us with y plus 4 on top and y minus 4 on the bottom. Okay, here's another example. So we have a binomial on the top and the bottom. So we're going to see if there's a greatest. First, we check for the difference of 2 perfect squares. Well, we have the difference, but 2 is not a perfect square, neither is 10, so we can't take the difference of 2 perfect squares on top. But we do have a greatest common factor of 2. So if we factor out a 2, that would leave us, we can divide each term by 2, that would leave us 2 times x minus 5. So that's how we factored the top. Now on the bottom, we actually have the difference of 2 perfect squares, because 25 is a perfect square and x squared is a perfect square. So if we were going to factor that, the square root of 25 is 5. The square root of x squared is x. 1 is minus, 1 is plus. So what does this look like? I wrote that all down, but I'm going to erase it and show it with the PowerPoint. Here's what it looked like. What we just did, we took out the greatest common factor of 2 on top. Now, you have to look sometimes for something called opposite binomials. Here's what we mean by that. On the top, you see an x minus 5. On the bottom, you see the 2 terms reversed. It says 5 minus x. Well, with the commutative property, you could rearrange this, and then this would be minus x plus 5, which has the same thing as x minus 5, but it's the wrong signs. So here's what happens. If we factored this out, if we just rewrote 5 minus x with the commutative property and wrote minus x plus 5, and then we factored out a negative 1, and we divided each of these terms by negative 1, that would give us x minus 5, which is the same thing that we have on top. So when you learn to recognize these opposite binomials, you know that they can cancel each other out, but I had to factor out a negative 1. So you have to add a negative to it. Okay, so when you see opposite binomials, which means the x minus 5, the 5 minus x, they're just in different orders. You think, I can cancel those out, but I'm having to factor out a negative 1 out of one of them. So when I do that, then I have to add the negative out front. So these cancel, but I have to add the negative 1 or the negative sign out front. So what is left? We have negative 2, factor out a negative 1. We have the negative out in front. We have 2 left on top and 5 plus x on the bottom. So we refer to this as opposite binomials. We want to look for that. Let's practice that again. On top, we have a binomial. It is not the difference of two perfect squares, but we can factor out a 2. That would leave us with 3 minus x on top. On the bottom, there is a greatest common factor. Remember, the first step of factoring is always to check, is there a greatest common factor for all three terms? All of them have a common factor of 2. So if I divide each term by 2, that gives me x squared minus 2x minus 3. Now I have a trinomial with a leading coefficient of 1, so I use my reverse FOIL. So I have negative 3, and I think of factor pairs for negative 3, 1 times 3, and I need them to add together to get a negative 2. So that gives me 2 on the outside, my floater. Then I have x plus 1, x minus 3. Okay, now let me erase this and let the PowerPoint pull it up, or it's going to look really, really messy when I do this. So what we just said is that we factored out the 2 on top, and that left 3 minus x. We had the greatest common factor of 2. We're going to factor that bottom, and when we factor the bottom, it gives us x minus 3, x plus 1. Now, we have a 2 on top and a 2 on bottom. 2 divided by 2 is 1, so they cancel each other out. Here's where I look and I see opposite binomials. 3 minus x and x minus 3. They do cancel each other out, but I have to add the negative 1 that I factored out in the front. So when you do all of that, what is left? Nothing on top, so I put a 1, x plus 1 on the bottom, and there's that negative sign from factoring out the negative 1 from the opposite binomials. That is part 1. I'm going to pause the video now, and in the next video we will do part 2.